Well, I don't want to finish this little example without showing you the possibilities to see the results in the different working planes. Let's go to the Results tab. We remove the rendering, but we mark the materials to see everything with different colors, and as you can see, we have the results of the different loadings or envelopes. Let's select, for example, the envelopes. If we want to see all the results for a structure like this one, it's not going to be very clear. That's why we have defined the working planes, so we will activate them and select which one we want to see. We start with the intermediate floor. We would have it here. Then we could go clicking with the arrow and seeing the different working planes, so everything would be much clearer. And when we get to the working plane that we want, we remove the 3 dimensions and then we would have this much clearer. If we don't want to see the background planes, then, as we already know, we click on the controls. We remove the non-active elements and the background planes disappear. We can see the rest of the elements in 2 dimensions in order to analyze their values. In addition, if we have a certain working plane selected, and, for example, we want to see the axial forces in the members of this working plane. If we click on the numerical result output, we would see the axials only for these elements, that 90, 91, 92, 93, 94, up to 98. Those would be the elements that we are receiving the information about. If we then go back to the 3 dimensions or remove the working plane, then all the elements that we will see the results of will be all the members, as we can see. Another interesting thing you can do is create a partial system, or we can simply select all the elements parallel to this one here, with which we would be selecting all the pillars, and see numerical results of the axial envelope or graphical results for axial envelope. And as you can see, we would have all the results in the vertical elements. That is, if we want to check a result, we don't need create a partial system. But we can use the bar selection tool to do it. We can select, for example, all the members that are parallel to this one here. And we would already have it. We can also see how is the distribution that we were doing. For the hypothesis of surface loads, for example, if we see the roof self-weight, and we see the envelope of bending Y moments, for the elements that are parallel to this bar here, we see that these are the forces that are carried by the main beams. But if we look at the forces that are carried by these elements here, we see that this is exactly how we want it to work. That is, having said that these elements here are in charge of distributing the surface load, makes them have these internal forces, that is, they are working. If we had indicated that the load-bearing elements, instead of being the U-oriented ones, they are the V-oriented ones, when we go to the results, we can select again all the elements parallel to these ones from here. And as you see, they are no longer working in a logical way. They are hardly working. We want things to be as they were before, so we go back to surface. We leave it as it was. We say that the load-bearing elements are the ones that are going in the U direction, and when we go to results, and select all the elements parallel to this direction, we see that they are again working as we want them to, with a more logical behavior, in which each of the elements works. Otherwise, hardly any element would work.